Hey everyone, today let's see how we can use auto-scaling group in order to scale in or scale out our instances. So let's go through a architecture diagram first, and then let's go and create auto-scaling group in order to control our instances using AWS console. So how it goes, first one user or as many as users will send request to your application load balancer, and your application load balancer consists of your EC2 instances, and this particular application load balancer forwards the request from the user to different instances that are under the application load balancer. And right now we initiated two different instances in two different availability zones because it provides high available and reliable architecture. So if one of the availability zone failed for some climate reason, the other availability zone is going to be available for your application in order to send response to your user requests. But what happens if there is a huge increase in the number of users accessing your application load balancer or your application, and we had only two EC2 instances who cannot serve all the requests that you are receiving. Initially you got only one request, but all of a sudden due to some Christmas or shopping season we got like thousands and thousands of requests coming to your application. Then we are using a auto scaling group. This auto scaling group is connected to your target group, and this target group consists all the targets, and this will check your instance health checks. It's consider your instance health checks. And the auto scaling group can do scale in or scale out of your instances, which means either it can decrease the amount of instances in your application or it can increase the amount of instances in your application. Right now you got only two instances. While uh, while you are choosing your parameters or components of your auto scaling group, you're gonna define the capacity, the minimum capacity and the maximum capacity of your auto scaling group. And let's say if it is 2 as minimum capacity, you got only two instances within the auto scaling group. And if your maximum capacity is like 5, auto scaling group is not going to scale out more than 5 instances. So it can only scale out to maximum of 5 instances. And when this auto scaling group scales out on what basis, which is CloudWatch. So whenever huge number of requests are incoming to your EC2 instances, the CPU utilization metric of your EC2 instances is going to rise. When your CPU utilization is more than 70%, and CloudWatch going to trigger your auto scaling group, and then auto scaling group is going to scale out your instances, which means increase your number of instances. So instead of 2, it is going to be 5 instances here, so that the CPU utilization will be less than 70%, and all the requests from the users, different or many users, will be addressed and responses will be given. This is what we're going to implement in our AWS console. So in order to create a auto scaling group, first you have to create a launch template. So what exactly a launch template is? A launch template is something that a auto scaling group uses when it's going to create your EC2 instances. So whenever you create a EC2 instance on your own from the console or from CLI or from SDK, what you're going to do, you're going to specify some components, right? Let's say launch instance. You are going to give name, or you're going to select Amazon mission image and instance type and some VPC settings, especially security group and EBS volume kind of thing. This is the same, but instead of asking you every time, we're gonna give it in the launch template, and auto scaling group is going to use your launch template. So let's create a launch template for our auto scaling group. Launch template for auto scaling group. You can describe anything if you want to, and you can give the tags. Right now I'm not adding any new tags, but whenever you're working on a project, it is always recommended to add tags, so that especially for your billing or cost management. And now you're gonna choose a Amazon mission image. So what exactly is Amazon mission image? Let's discuss it later. But as of now, make sure you choose free tier and then you look at the instance type. You go with T3 micro, which gives you 2 CPU units and 1 gigabyte memory, which is RAM. And do you either use some key pair or you want to create a new key pair? Right now I'm using a old key pair of mine, which is aquarium instances key pair. I created this when I'm working on an aquarium project, but you can use any key pair for any instance as long as you have that particular key pair with you, so that you can SSH into the instance. and then we can either create a security group or select existing security group. But let's create a security group. What is your security group? Since I'm creating a security group especially for this launch template, I'm just adding similar name and add security group rule. So if you want to add a security group rule, you can add security group rules here. We mainly have HTTP traffic and SSH traffic to our application. So right now I'm using any allow traffic from any source, which is not actually recommended, but let's keep it this way to keep things simple. And you can also add SSH from everywhere. And I'm leaving EBS volume as it is, and in advanced details I would like to add something in the user data so that whenever you try to access this particular uh, instance which is created by this particular launch template, I want to show the IP address of this particular instance, and I want to show you the uses of application load balancer, how application load balancer is switching or sending your traffic to different instances. So I had a user data which is already with me. I would like to bring it out. Now I created a launch template. Okay, we got something. A security group description is required. Okay, hello, HTTP and SSH. Let's create the launch template. Now we created the launch template. We can view this one. So now what we're going to do? Now we are going to create a application load balancer and also target groups. So whenever you create a auto scaling group, you can attach the target group to the auto scaling group. Let's go to application load balancer. Let's create, there are different types of load balancers. As of now, especially when you choose application load balancer, it mainly depends on what kind of traffic you are sending to your application or AWS resources. Load balancer name, auto scaling group, application load balancer, internet facing load balancer IP address. This is all same. And so in what availability zones you want your application load balancer to be available. Right now we are selecting all the availability zones. And the security group, you can either use default security group or you can use our launch template ASG security group. It is somewhat better to use same security group for your testing purposes because it would make it easier for us. And now we have to create a target group. Since we don't have a target group, let's add a target group. No target group. I think we have to create a target group, and let's create a target group first. Target type all instances. We will add instances. Auto scaling group target group. Protocol HTTP or AT. VPC similar protocol version, similar health checks. We don't need to change these things. And next. And right now we don't have any instances attached to it. Create target group. Now we create a target group, but this particular target group doesn't have any instances. So let's get back here and let's add our target group. I think it is not being loaded. We have to reload this one. Let's take load balance internet facing. We are not changing anything, but we are choosing all the availability zones. We are going with our launch template, auto scaling group, security group. We are selecting auto scaling group target group that we created just now. These are different services that we can use for application load balancer. We can look into them later. And this is the summary that we choose for application load balancer. This is the name, and it is an internet facing. And when you look at the VPC, we are going to access all these availability zones. And this is our security group, which is same for our launch template and application load balancer. And whenever there is a HTTP traffic over port 80, we are going to forward it to our target group. And let's create our load balancer. Now we got our load balancer, but whenever you try to access your load balancer, we got no instances available for us or there to answer us. See, this site can't be reached. Okay, let's now create our instances using auto scaling group. Create an auto scaling group example, and now we have to use the launch template. So we are using the launch template we created earlier. Our launch template might have different versions. Right now we had only one version, and we're going to use next. And these are the subnets that you're gonna define where auto scaling group can create instances. Let's keep it like this for right now and click on next. No load balancer, attach an existing load balancer. We had a load balancer, right? So let's attach it. Select a load balancer to attach. Choose from your load balancer target groups. So now we had this target group which is attached to our load balancer. So I am attaching this particular target group here, and then let's keep them all same or default as of now. Click on next. What is your desired capacity? Let's say our desired capacity is 3, minimum capacity is 3, and our maximum capacity is 6. No scaling policies. These are all something default. We can talk about them later. And let's click on next. We are not adding any notifications as of now. Next. And this is our complete summary. Auto scaling group name. This is the launch template we are using. And the second, choose instance launch options. So where we can launch our instances. We can launch our instances in all of the following availability zones. So how it's gonna distribute is balanced best effort. So it's going to balance, trying to create, since we said minimum capacity is 3, 1, 1, 1, and whenever it's at scale out maximum capacity, it's going to be 2, 2, 2. Integrate with other services. So we are integrating our auto scaling group with our application load balancer over this target group. So all the instances that are created will be shown under this particular target group. And let's create our auto scaling group. Whenever you create an auto scaling group, all your instances will be automatically created within few minutes. So how you can find it out? Maybe you can just go to your instances and see 3 instances started running, but the status check are not yet ready. It's still initializing. We can wait for a few minutes, and let's try to access our instances individually, and then we can access our application load balancer and see how our application load balancer is sending requests to different instances on different requests. Now we got our 3 instances running, and let's see how we can access these instances using application load balancer. So we can go to our application load balancer, and we can access our application load balancer using the public DNS name. And when you send a request to our application load balancer, it's gonna forward to any one of the instances, which is 16E1 as of now. So if I refresh and send a new request to my application load balancer, it is going to send this time the request to some other instance which is under this application load balancer. So we got 3 instances, right? So it is going to send request to a different instance other than 16E1. See, now it sent the request to 5FO42. And again, if I refresh, this time it sent the request to 2337. If I refresh again, it's 167, different one. Every time I send a new request, application load balancer is going to send this request to a new instance. Okay, so now let's see how an auto scaling group scales out our instances whenever there is a huge amount of CPU utilization, like more than 50% or more than 70%, whatever we choose. We can run a stress test on any one of these instances and see how our auto scaling group is scaling out. Let's see how it scales whenever there is a stress test on our particular EC2 instance. So we can't find any auto scaling policies over here. So I think while we are creating the auto scaling group, we haven't defined any scaling policies. There are mainly dynamic, predictive, and scheduled actions. I'm not sure I report predictive as of now, but dynamic scaling policies is these policies depends on a CloudWatch alarm. So whenever your CloudWatch alarm meets a threshold, let's say if we say a CPU utilization should not be greater than 50%, and one of your instance crossed the CPU utilization more than 50%, then we can say it met the threshold. In those cases, the scaling policy will be triggered, and the auto scaling policy on the auto scaling group will scale out from 3 instances to our maximum limit of 6 instances. Schedule action. So if you already assume that every day at 5 o'clock you will have a huge traffic to your website, then you can schedule this action so that the number of instances at that particular time will be increased. So these are like schedule actions. So let's create a dynamic scaling policy, and here we had target, step scaling, and simple scaling. Let's learn about them later, but right now we can go with target scaling policy. And here the metric type we are using is average CPU utilization. So it tracks the average CPU utilization of your instances and then decides which instance, then decides when the scale out policy should actually start. The target value, we made it like 50% of average CPU utilization and instance warm up. So what exactly is instance warm up? So before sending any traffic or before making this new instance or marking it as available, auto scaling group will wait for the warm up time. The default one is 300 seconds, which is 5 minutes, but we can make it 60 seconds. So even if your instance is ready and if your warm up time, let's say 300, so it's 5 minutes. So if your instance is ready in 1 minute, but your warm up time is like 5 minutes, so auto scaling group will not make this instance as available until it crosses the warm up time, which is 5 minutes. But since we doesn't have such a great software or such a huge user data which is required for booting up, or which takes more time to boot up for our instances, we are going with 60 seconds. It's like a minute. And we're going to create the scaling policy. So what this scaling policy does is it's going to create 2 CloudWatch alarms, and we are going to look at them. Here is our CloudWatch alarms. Oh, I think it's taking some time to create these alarms. Yeah, we got 2 CloudWatch alarms. We don't have any sufficient data right now, but we can just go through it and learn. One of the main things I highly request all of you guys to do is go through every part of the console. Try to understand the tags, actions, history, parent alarms, details. If you go through them slowly, try to understand what's happening. Look at event bridge rule so that you will understand what exactly is event bridge rule and everything. So what exactly this alarm says is, this is basically a little bit on description, but the main thing we should look at is threshold. So when our CPU utilization is more than 50% for 3 data points, and each data point is calculated at a limit of 3 minutes. Okay, my bad. So the main important thing is threshold. So when our CPU utilization is greater than 50% for 3 data points, the threshold, the alarm will goes into in alarm state, and then the auto scaling group will trigger the scale out policy, and this particular CloudWatch is going to check the metric for every 1 minute. So let's say in the first minute it is 40% of CPU utilization, and the second minute it is 55, and third minute it is 65, and even in the fourth minute if it's still more than 50, then the alarm will be triggered. But if it is 30 in first minute, and second minute if it is 70%, and in the third minute if it is again 30%, which is less than 50, this alarm won't be triggered. So your metric should be more than 50% of CPU utilization for continuous 3 data points. That's how it works. So what can we do now? Since we already set up our auto scaling policy, we can SSH into our EC2 instances. We got 3 instances. Let's SSH into 2 of our EC2 instances and run a stress test on them. So the auto scaling policy will trigger our auto scaling group, which in turn scales out our number of instances from 3 to 6. Okay, now let's connect to our instance using EC2 instance connect. I already clicked on the connect, so I had a new tab opening where I connected to my instance. So here I had an issue when I'm using the stress command. So it says stress command not found. So I installed the stress related package, and now I can run the stress command. So it is working, and let's connect with another instance and try to run similar stress command. As I told you earlier, so if you run the stress command without installing the stress package, it won't work. So I'm installing the stress package first, and then let's copy this command that we got and run our stress test. So now, since this is happening, what we can do is we can go to our CloudWatch alarms and try to see how our alarm is showing any kind of data. So right now this is already in alarm CPU utilization is less than 35, but our scaling policy only works, our auto scaling group scaling policy only works when our CPU utilization is more than 50. And slowly here you can see our CPU utilization is increasing in percentage. Now right now it is 36%. Maybe we should wait for 1 more minute. So now let's see, in our alarm it shows the CPU utilization is more than 50% for a long time. Let's see what happens in the last 1 hour. It is more than 50% for quite a bit of time. So now let's go to our auto scaling groups or instances maybe. Let's see how many instances we got. And if you go into our instances, see, now we got 6. Right now it's 5. I think it's still trying to load 1 more instance, which we can find here. 1, 2, 3, 4, 5, 6. It's still initializing the statistics. So our auto scaling groups scale out policy got triggered because of our stress test. Right now, we can also do this. Then we can go to the application load balancer or load balancer and try to access the DNS of our load balancer. And see, now we can find almost 6 different instance IDs and 6 different private IDs. Let me refresh and reload this page and see how it works. Now it's 4F. I am just concentrating on the last 3 digits of our instance ID. Now it's 34F, CE4, 3D1, 196, 34F again, CE4. See, this is how it works. And once you stop this stress test on our instances, we can, in a safe way, the scaling policy of our auto scaling group will work and all the instances will be disappeared. Like from 6 instances, it comes to the reserved capacity or minimum capacity, which is 3. And let's see how to safely reduce all these instances. One main thing is, if you want to delete the instances that are created by auto scaling group, and if we select all these instances and if we stop this instance using our instance space, once these 2 instances got stopped, auto scaling group will automatically triggers 2 new instances, because the auto scaling group don't know that you stop these instances. It thinks that because of some health checks, these instances got stopped and it should trigger 2 new instances. So instead, if you want to delete any instance that is created by auto scaling group, what you have to do is you have to get into the auto scaling group and you have to edit the auto scaling group. Now we have to edit our desired capacity to 0 and our minimum capacity to 0, so that all these instances will be automatically deleted by your auto scaling group. And this is how you have to safely delete your instances which are created by auto scaling group. Stay tuned and I will come back with a new topic. And this is how we use AWS auto scaling group to scale in or scale out our instances based upon any scaling policy that we decide. And always make sure you learn about elastic load balancer and application load balancer is one type of it, so that you can send requests to different instances, and only one of the instance, if there is any problem with one instance, our application load balancer will automatically send the request to another instance, so that the customer or the client doesn't see any downtime. Thank you for watching the video.